Hello dear students, today we'll be discussing about the 8th chapter, that is electromagnetic waves or EM waves. So this displacement current you don't have in syllabus, but it is a very important concept, so please understand what is displacement current. Displacement current basically is a current produced by changing electric field. Okay, so the expression of displacement current ID will be epsilon naught d phi upon dt, where phi is the electric flux. So basically it is a current produced by changing electric field. So electromagnetic waves, what are electromagnetic waves? They are basically wave in which electric and magnetic field vectors change sinusoidally and are perpendicular to each other. So basically they are transverse waves. एउटा डिरेक्सनमा इलेक्ट्रिक फिल्ड गयो भने त्यसको परपेन्डिकुलर डिरेक्सनमा म्याग्नेटिक फिल्ड हुन्छ अनि त्यो दुईटैको परपेन्डिकुलर डिरेक्सनमा डिरेक्सन अफ प्रोपगेसन हुन्छ. Okay, so the general expression of electric field and magnetic field looks like this. Ex, x is the direction of propagation of electric field, E naught sine kz minus omega t. K is called the wave vector, omega is frequency, t is the time period, and k the wavelength of a wave. Lambda, relationship between k and lambda is k equals to 2 pi upon lambda. K is called the wave number, I have already told. So what are the properties of electromagnetic waves? They are transverse in nature, they do not require any medium to travel, and the speed of light is given by 1 upon mu naught epsilon naught, that is 3 into 10 to the power 8 meter per second. The exact number of speed of light is 299792458 meter per second, but in numericals we use rounding it up, we write 3 into 10 to the power 8 meter per second. Okay, in any kind of material, in dielectric material you have permittivity and permeability mu and epsilon. Mu is basically mu naught into mu r, and epsilon is basically epsilon naught into epsilon r. Mu naught and epsilon naught are the permeability and permittivity of free space. Mu r and epsilon r are basically the dielectric constant of that particular material. Okay, permittivity of that particular material. So it basically becomes C upon mu r epsilon r. So you can see the speed of light decreases in a medium. The highest value, this basically 1 upon root over mu r epsilon r is the refractive index of the medium. Okay, refractive index root over mu r epsilon r c by n, and we know refractive index is always higher than 1, so c divided by a number greater than 1 will be always lesser than c. So these are the small things which you need to remember. So in EM waves, the ratio of amplitude of electric and magnetic fields is always constant, that is equal to the speed of the EM waves. C will be equals to E naught by B naught. This is important relationship. So how EM waves are produced? They are produced by accelerated charged particles. So energy is equally divided as electric and magnetic. Next is we have Poynting vector S, which is given by 1 upon mu naught E cross B. So where will be the direction of Poynting vector? Can you tell me? So it will be along the direction of propagation of EM wave. The electric vector is responsible for the optical effect of the electromagnetic waves. So electric field vector is also called light vector. So कुन चाहिँलाई light vector भन्यो भने electric field vector लाई light vector भन्छ. Intensity of electromagnetic radiation is the energy passing through unit area in unit time and is given by I. So I is energy per unit area per unit time. Okay. So how to produce, this is frequency, resonant frequency of the arrangement given here. You can see, read it, is given by 1 upon 2 pi root over LC. The results in oscillation of charges on plates with such high frequency, and hence an oscillating electric field is produced across the vertical gap between the two spheres. Okay, so this oscillating electric and magnetic field then propagates the space in the form of EM waves. So what are EM waves? Basically EM waves is oscillating electric and magnetic field, that you need to understand. So electromagnetic spectrum, we have radio waves, frequency 10 to the power 4 to 10 to the power 8 hertz. The lowest frequency, wavelength, please remember the wavelength and the frequency are inversely proportional. एउटा बढ्यो भने एउटा घट्छ. Okay, If one is increasing, one decreases. So lowest frequency, highest wavelength is radio, then the frequency is increasing, wavelength is decreasing. Okay, so visible range is around 700 to 400 nanometer is the wavelength range for visible light. Okay, so this table you need to remember. So this was your electromagnetic spectrum. Hope you guys understand it. If any problem, feel free to ask, we can discuss. Thank you.